Hi, it's vintage computer teardown time again. We love vintage computers here on the EEVblog, and this one is going to be quite interesting. It's one I had never heard of before. It was sent into the mailbag segment by Alex from Japan, so thank you very much, Alex. This is the Sharp X68000 home computer slash gaming machine. It was a personal computer from 1987. This is one of the original models. In fact, Alex says it's the model CZ600CB. It's got a 10 megahertz processor. Guess which processor? And a whopping 1 meg of RAM. And apparently this was a quite highly sought after machine for gamers because it had lots of real arcade game emulations on here, like real proper emulations and things. So it's a real interesting construction. Yes, it's designed to be vertical like this with the dual floppy drives, and it's even got a little pop-up carry handle which doesn't work that well anymore. So I thought we'd tear it down and see what makes this puppy tick from 1987. You know what we say here on the EEVblog, don't turn it on, take it apart. So this thing's a little bit annoying to get on camera with this vertical profile here. They did actually make ones with horizontal profile, so we'll just flip it on its side like that and take a look, shall we? Down the up the top here, we've got just some status LEDs. Timer, not sure what timer is for, but high resolution mode. Two 5¼ inch floppies, 5¼ for the win, awesome. Mouse port, keyboard port, volume control, one joystick port on the front, the second one's on the back, and some headphones as well, and a soft power button. Feels like a bit of a clunking power button, but apparently it is a soft power button. That was a bit of innovation for the day. And on the top, upside down, so all the electrons are going to fall out, we have a reset switch and an interrupt switch. I love it. Let's just interrupt the operating system, which, by the way, it uses its own custom operating system called Human 68K, and it's like got a similar interface to DOS, apparently, but yeah, it's not compatible. It's its own thing. So this is actually the original one released in 1987, the CZ600CB, and there were many other models, like a dozen or so, released in the years after that, up to 1993. And on the back here, we have a couple of expansion slots. We've got a remote interface. We've got a printer interface with just a header ribbon cable there. We've got a hard disk interface, which is not SCSI compatible. It uses a Japanese variant of SCSI, which was their own thing. Expansion floppy drive. Not sure why you'd need more than the two internal floppies. Anyway, a big clunking power on-off switch, in addition to the soft one on the front. We've got AC output. This is 100 volts, of course. I'm not going to plug it into the 240 volt mains here in Australia. We've got a second joystick port, audio in and out, RS-232. I don't know if you could ever get like a modem or anything for it. Anyway, the main monitor output was analog RGB, and it's got image input as well. See-through color, not quite sure what that does. TV control and stereoscopic, which I believe somebody mentioned as in, like, it can do like cinema type 3D thing with the different colors. So to produce stereoscopic images, very interesting. And curiously, it's got two ground terminals here labeled FG. So I guess you could ground systems together. Now this thing cost 375,000 yen when it was released in 1987, around about 1,500 Yankee bucks or thereabouts. So, you know, it wasn't a cheap low-end machine, especially for the day, with 1 meg of memory and a 10 megahertz 68,000 processor in it. It was quite a high-end machine, and yeah, apparently it had quite a lot of pixel perfect arcade game ports. That's why it was extremely popular with the gamers, and apparently still is. Has some niche appeal and things like that. I have no idea how to take this thing apart, so I've just taken off some screws I found on the bottom, but And Alex said these things are notoriously bad, have notoriously bad power supplies in them, so yeah, that'll be interesting to look at. So I've got the bottom screws out, but geez, I don't know. These two things are screwed together somehow, and there's some screws on the other side, but how do I separate the two modules? Geez, this is a weird ass teardown, that's for sure. Please excuse the when I put my hands in, it overexposes and stuff like that. That's a problem with recording black objects like this. It's sort of, if I got auto exposure in, it sort of gains it up. I can turn off auto exposure so it doesn't do that, but yeah, anyway. I'm getting somewhere. I've got an expansion cover off. There were 3 screws here, but there's like screws under here, so I don't know how to get to those. And are there plastic clips, retaining clips under there? Ah, goodness, hang on. Does this feels like it might slide or pull off or something. Yep, there could be a retaining clip under here. Let me play with that. Aha, just had to give it a bit of a hit on there, and ta-da! Ah, we're in like Flynn, but unfortunately we got some shielding in the way. Bummer. We've got the lid of the first module open, and it's clearly the processor module because, well, there's our 68,000. I'll show you that up close for you fanboys in a minute, but it's surprisingly chock-a-block. Huge amount of memory array up here, and, well, there's our battery. It hasn't leaked, and it's actually surprisingly tidy, actually, clean and tidy, this one, because the bottom, well, the other module, I'll call it, the second half of this thing actually has the fan down here. So this has got the mains power supply, and it looks like some, hard drive, some floppy drives and the expansion and stuff like that. But all the processing grunt is all up here. But look at this second board here, which we'll have to take out. There's a huge big PGA device up here, pin grid array, none of these BGA ball grid array rubbish, no siree Bob, and it's very well annotated too. All the board, all the component designators, look, even the caps have cap symbols on them, very, very nice. We've got another large memory array up on here, so I'm not sure what else is doing on that board anyway. They obviously couldn't fit on the main board. Surface mount devices over here, pretty fancy for 1987, and we've got a and Sharp branded ones as well, because Sharp are a big semiconductor manufacturer, so it'd be no surprises for seeing them roll a couple of their own chips at least. And there it is, the 68,000 processor. A lot of people are going, we are not worthy, we are not worthy, we are not worthy. Anyway, yeah, socketed, but it's not a genuine one. It's a Hitachi rip-off one. Well, not rip-off, but they did second source it, I believe. Now, this is interesting, Buddha. Now, I had a look, and this is apparently the system controller. That's the code name for the system controller chip. They didn't use that in all the models. This Buddha system controller chip, that'd be a custom ASIC manufactured by Sharp, presumably. It's got Sharp brand on it anyway. Sharp did a ton of their own ASICs and semiconductors, so yeah, no surprises, they could easily do that. But this was not used on later ones. They upgraded and gave them different code names as they released bigger and better versions of this system. Anyway, this one's the Buddha. And check out these 7.4 ALS 244s. I just mentioned this because they're ALS. They're not exactly low power devices, although they're advanced low power Schottky. That's what ALS stands for. But no wonder this thing, these old school machines, took like quite a bit of power, even though they're only in quote marks, running at a processor speed of 10 megahertz. And no surprises for finding a HD 63450 next to that. That's the matching DMA, direct memory access controller, for the 68,000 CPU. And these two socketed puppies here look for all the world like mask ROMs. There we go, they're not windowed devices. You can actually see maybe the a round divot in there, but yeah, these are almost certainly the mask ROM firmware in the thing. And bingo, we have a date. Look, 8730, 30th week, 1987. Awesome. And these surface mount parts here, these are very interesting. They've all got, once again, custom Sharp parts by the looks of it. You might think, okay, look at the array of them, their memory or something like that. I don't think that's so. They all seem to be like a separate controller. Look, IX0894, IX0893, IX092, etc. So it's almost, they got like a, a separate custom chip and a whole, like an array of 6 of these. What are they doing? Some sort of memory access thing or something perhaps, but we've already got the DMA controller here. What are these things? I got no idea. Maybe something to do with the expansion bus, maybe some sort of custom expansion controller perhaps. I'm not sure. Now I'm trying to get the main board out here. This front panel here does actually clip out as well from the underside, under there I think, but I can't quite get it at the moment. But I think I can actually wiggle the entire board out if I'm very, very careful. Get it over this metal lip here or something and it should lift out. But geez, yeah, it's kind of tricky business. I got the floppy cable off and ta-da! We're almost out. Oh, it's a bit dusty down the bottom, but bingo, we got it. Awesome. So there it is. We're in like Flynn. We've got the whole module out here, and that wasn't actually too bad at all. So main processor board on the bottom here. This top board with a separate memory. Clearly the video card and the big PGA and looks like another couple of Sharp system ASICs there. That's got to be all video card here, and the RGB is down here. It connects. I think it must be doing all the video processing down there on the bottom. That's all I can whoop, there we go. Oh, we have Cynthia and Cynthia Jr. Let's check them out. Well, hello Cynthia and Cynthia Jr. Another big PGA device, because this is the board-to-board connector here that goes up to the video board. So I think this is Cynthia is some sort of video interface controller, something like that. Not actually the video controller itself, that's the other PGA device up on the main board, but yeah, and then another dip package there. Why they're doing a dip package for Cynthia Jr. there and not an SMD like they did for the others, I'm not sure. But anyway, it is all top-sided load, except for a little bodge capacitor on Hysteria here. I love the names. Brilliant. Ugh, look at that. We better rip that battery out quick, smart. It is Gonski. It's made in Japan as well. And yeah, look, you can see some corrosion happening around here. Doesn't look that bad, and it's extended over to the steel case of this oscillator over here. Ooh, thankfully it hasn't gone too much further. Shouldn't really affect it, I don't think. Maybe there might be a trace broken, might have gotten onto the copper layer in there. Not sure though, let's hope not. There you go, that cleaned up rather nicely. I think we caught that sucker in the nick of time. The negative pad of the battery down there is a little bit cactus, so yep, just got that one. Whew. Now the frequencies of these two crystals are rather interesting. Look at this, 69.55199 megahertz and 38.86363 megahertz. Now, what are they doing? Now, my first thought there was that, of course, these are a higher multiple of the color burst frequency, because this unit is supposed to have an NTSC video output. So yeah, but you divide that by the 3.579545 megahertz NTSC color burst, and well, it's not an exact multiple of either of those, and neither is the power color burst frequency either. Well, check out Cynthia. Wow, ceramic package, metal top. Look at that, beautiful. And poor old Cynthia Jr.'s feeling very Marsha. So why would they have split Cynthia up into two chips like this? Well, it's a good question. And of course, as I said, they consolidated, I believe, in the following models into the one Cynthia chip. So they absorbed Cynthia Jr. into Cynthia. So why didn't they build Cynthia Jr. into Cynthia to begin with? Well, my educated guess is, well, they designed Cynthia and then they prototyped it and, well, it was okay. And then they came along and went, oh, it'd be nice if we added this, or oops, we forgot to add this, and bingo, rather than respin this whole chip, they just did another little tiny little thing for Cynthia Jr. here and whacked it in a 28-pin plastic package. Thank you very much. So there you go. That's the complete main logic board minus what I presume is the video board and processor on top. We've got ourselves yet another Sharp custom ASIC here. It's called ET, I think. Phone home. Thank you very much. Another oscillator here. That's 40 megahertz. So that'd be divided by 4 to get the main 10 megahertz system clock and 20 megahertz and other stuff that it needs to do. And then we've got all our video output section down here. We'll take a quick look at. So Cynthia and Cynthia Junior. I mean, Cynthia here could be the main video processor. I'm not sure. But then, what does that one do? So here's the video board, nothing, 2 custom ASICs here, Vinas 1 and Vinas 2, whatever the hell they are. We've got, it says reserve over here, so I don't know what reserve does, but got some weird ass names. And then we've got the VSOP. That is what looks like, well, you know, P probably stands for processor, V probably stands for video, so video system output processor, operational processor, or something like that perhaps. It's another very sexy ceramic package from Sharp. Interesting. Look, I've got some, I've got to be super fast, 74F series. Pissing away the power here. And curiously, they've got 3 of those socketed there, the 74Fs. What, they expect those to fail, or maybe they were hedging their bets and goes, maybe we can get away with ALS, I don't know, damn it, we'll have to put F in for the final production units. But hey, we've got an F245 over here, and of course all of our video memory in zip packages, which we saw on the main board as well. But what this D25 image in connector, it was labelled on the back, is on this board, I don't know. Is it some sort of video capture thing? It doesn't seem to have any, hardcore hardware associated with it. I don't know. If anyone's got any clue what image in does, then let us know. Some sort of display synchronization thing between machines, perhaps? On second thought, if you follow these traces down here from the connector over here, then bingo, it's going to this reserve controller by the looks of it. There's a chipset near the crystals here called Hysteria. Once again, a custom Sharp ASIC. Geez, they really went to town on this thing. So what does it do? Well, most likely some sort of clock controller, timing chip, something like that. It's down here. Now there's a real-time clock crystal here. There's a real-time clock chip right there to match up with that. But this is the main oscillator, of course. And tucked away down in there is the MC68901. That's the multifunction peripheral chip for the 68,000 CPU. It's a bit of a big beast physically, but it's got the timers, counters, interrupt control, and all that sort of miscellaneous stuff you need in a PC. Not sure what the deal is with that symbol there. Anyone know? And then our main system memory here, this is the DRAM. These are in single inline packages. You don't see those anymore these days. But in terms of board mounting density, very, very nice. So it's actually a nice package. I like it. These are MB81256-12s. You can probably, just see that in there. And 120 nanoseconds, of course, access time. That's what the -12 on the end means. And the 256 is a dead giveaway that this is a 256 K-bit DRAM, not megbit. K-bit, thank you very much. We're talking 1987 here. And, of course, 8 in a bank like that makes 1 byte. So you've got 256 K bytes, 512, and then total of 1024. 1 meg of system memory. Awesome. Now for me, one of the interesting things to note about this whole thing is look at the amount of standard 7400 series logic, as we saw mostly ALS, but some other families like S and S, and just straight 7400 even on here. And that's strange considering that they've rolled their own chips everywhere else, right? Sharp are one of the big semiconductor manufacturers. They can do this sort of stuff. Why they didn't consolidate a lot of this other miscellaneous stuff into at least CPLDs, for example, PALs and GALs and things like that, I don't know. They could have gotten a bit more density out of the thing. But yeah, maybe that was just easier at the, at the design time. Maybe they didn't have the resources. Maybe they were too busy doing all their big custom ASICs and everything else. So who knows? And here's the video output driver. We've got a Mitsubishi M51387P. That's a triple video driver, so an RGB driver, one for each channel, red, green, and blue. And there's our video output down here. So yeah, lots of analog stuff associated with that. That's basically pretty much the only analog stuff on this main design. And of course, it looks like the video is coming from Cynthia up here, because these are the board-to-board that go over to the main video board. But look, you can just follow the traces. Just follow the traces all the way down here. And this ET chipset is muddled in here somewhere as well. And this has got its own memory over here, Cynthia, or Cynthia Junior does anyway. It looks like it's for Cynthia, actually, if you follow some of the traces there headed up there. And that memory down in here looks super quick, 45 nanoseconds, MB81C78A. Turns out they're 8K bytes, 64K bit SRAMs, 45 nanoseconds. So they're really screaming along, taking the video very, very seriously there. So that's some sort of, that could be like the frame buffer or something like that, perhaps. I finally found some info on these custom chips. Well, not any detailed information, but just what each one does. So let's see how close it was. The ET chipset here, ET phone home, is the memory controller. The Cynthia and Cynthia Junior up here, they're a combo, as you would expect. That's the Sprite controller, actually. So, and this memory around here, I'm still guessing, but I would say that's probably might be the background plane memory, perhaps, because this thing can do up to 512 by 512 background, and as in background graphics and things like that. So, by the way, the video of this thing, quite advanced for its day. It could go up to 1024 by 1024 resolution in 16 colors, or 512 by 512 in 65,000 colors, as I said, with that background stuff, and it's got its own sprite controller and everything else. So really advanced graphics for the day. Actually, this memory here is most likely to be the sprite memory, because this thing does have 32K of sprite memory, so that adds up. That's what those memory chips must be doing. Just dedicated to the sprites. That's pretty impressive. And then over on the video board here, yes, the VSOP, as I suspected, is the video main video controller chip. Venus 1 and Venus 2 here, these are the CRT controller chips. Doesn't give any more info apart from that. And the reserve chip down here, yeah, I think I guessed that one was some sort of bank select, and that's exactly what it is. It's a video data selector chip. Some of these things are quite obvious when you look at them. I mean, this being a video data selector chip, just its physical location, all this memory here, right? We've got, large banks of memory, and generally, you might have to, in a video situation, you might have to swap those in and out. So it's no surprises for guessing that this physical location, sort of like, it's not wedged between here and here, but it's sort of, on the way kind of thing between the video controller and the memory, then yeah, okay, it's a video data selector. Not hard to guess. And most of the custom chips on here actually changed after this very first model. So all the following models used different chipsets. They consolidated Cynthia up here. They changed another one to the Ohm chipset. Very apt for the EEVblog. And there's the Messiah chipset, and yeah, all sorts of jazz. So yeah, they just completely revamped it for the following models. Now, as for the video memory here, I couldn't find any data on this MB81 461. 461's unusual because usually they have the size of the thing there, like, 256, 512. It's going to be, a power of 2 multiple. But I do know that this thing has 512K text video memory and 512K graphics VRAM. So that means this bank of 16 here must be 512K, and this one must be 512K. So that works out to 32 K bits per device. So yeah, I'm not sure of the part number there, but they are split into 2 banks, and that's very interesting. Separate text graphics memory and separate video graphics memory. That's why they need this reserve controller chip here for the video bank switching. These things are maddeningly hard to get off, to try and get these clips out of here and then slide it all back, and then it's got retaining clips in here, and I don't know, a little bit of plastic snapped off at the back there. It was, man. Anyway, got it. We're in like Flynn. First thing I'm doing, going outside, dusting this thing down, because it's all accumulated down the bottom. And here's inside the disk drive and power supply part of it. This is our power supply module, very well shielded, no problems at all. Two 5¼ inch floppies. These are the soft eject type, so they have soft eject buttons on the front. Very nice, you know, not the old-fashioned lever, you know, turn the lever and then get your fingers and pull it out. They actually had a motor to eject the disc. Very nice separate board up the top here for your hard drive interface and your floppy drive interface, and a relatively small fan on the top of the thing here. And then we've got our mains input and output over here with our main switch. Bit of insulating card here, but yeah, it's all a bit messy, but it does the job, I guess. Now, I don't know if the floppy is actually manufactured by Sharp or not, but it certainly does have a Sharp sticker on it. Now, down here on the baseboard, this is the Cillian System I/O controller chip. That's the code name. Now we get to the sound part of this thing. This Oki part here, this M6258V, that's a 4-bit 80 PCM sound chip, but this is where all the magic happens. This is a Yamaha YM2151. It's so famous, it's got its own Wikipedia page. Fantastic. This was used in the early DX series Yamaha keyboards, a very advanced FM synthesis chip for its day, and it's an 8-channel FM synthesis chip with 4 different operators, and very powerful thing. It was used in a lot of the arcade games of the era, like as in the big proper arcade game machines from, you know, Konami, Capcom, Namco, and Sega, and Atari, and all those ones all use this sound chip. That's why this thing, not only can it do pixel perfect graphic arcade emulations, it can also do, it's got the same sound chip used in a lot of those game machines. But this FM synthesis chip just doesn't work on its own, because it just generates the data. You need a DAC to convert that to audio, so that's paired up with another Yamaha. You can just see it tucked in there. That's the YM3012 DAC. And given the otherwise excellent systems engineering we're seeing in this thing, especially for like a first unit, like a first release one, it's got this big green bodge wire going all the way over there. Not sure what that one's doing. Oops. And also down on this baseboard, which we may not get to the rest of it, sorry, I am running out of time for this teardown, and to get into the other side of this, could be, like, to get the whole board out for photography and things like that, could be a bit of a pain in the ass. But anyway, down on the bottom board there, we're going to have a floppy controller. That's an NEC 72065. Apparently that'll be on the other side, and then there'll be the, well, it's not a SCSI controller, because this predates a SCSI controller. This thing uses what's called an SASI controller. It's a Shugart, that stands for Shugart Associate System interface, and it was a forerunner to SCSI, but updated models to this did include a proper SCSI controller. I believe SASI was, you know, fairly pin compatible with it, but technically different. And this Sharp LH8530A here, that's a serial communications controller handling all sorts of miscellaneous stuff. Now, I would love to try and get this power supply out for you, and I've tried, but there's something like holding it in the center by the looks of it, and it's getting really, really annoying, and I'm not sure I'm going to be able to get the thing out without sort of maybe like taking the whole damn thing apart. So, which is a bit of a shame, because Alex said that these things were notoriously bad, these power supplies, and they used dodgy caps, and you had to replace them all, and everything else, like all sorts of dodgy parts. So, yeah, I would have liked to have had a peek in there, but I can't get this off without getting this out to get the screws under here, and it's all just, it's all too much. Sorry, I'm running out of time. It's already Wednesday. So sorry, yep, I'm going to have to call it quits there. I don't have the time to take this down further. I'm going to have to stop filming, go edit, and upload this sucker. But thank you very much, Alex, for sending in this X68000 from Japan. Very interesting. I'd never heard of it. And a real state-of-the-art machine. Unbelievable. You got to remember, this was released around about the same time as the Amiga and the Atari ST, and it pretty much, spec-wise, and capability-wise, it just, blows those ones away. Everyone raves about the Amiga and everything else, but this thing is, you know, for its day, was absolutely incredible. And apparently highly sought after by the gaming fanboys. Who knew? Because of pixel perfect graphics, the sound, everything else of the arcade emulated games on this thing. So I don't know if this one works at all. I don't think Alex mentioned it, but yeah, you might have to clean up the power supply. It looks in pretty good nick. I see no reason why this thing shouldn't work or shouldn't be fairly easy to get going, although the floppy drives, don't know about the floppy drives. They could be the big thing. Apparently all the games ran from the floppy drives. Really, you didn't essentially need the hard drive in the thing. And this is actually a very well-engineered machine. I'm actually very impressed. Interesting dual tower format with the carry handle and everything else. I don't know whether or not they originally designed it that way. You know, they came up with the, you know, some artists came up with the, you know, marketing people or whatever came up with the concept of the dual towers like this, and then the engineers were given the task to fit it in, or whether or not it just naturally evolved into this sort of case. I don't know, but very interesting bit of retro computer history right here. The Sharp X68000, only sold in Japan. If they sold this outside of Japan, might have been incredibly popular. Who knows? So thank you very much, Alex. That was most generous of you to send this all the way from Japan. And if you like the video, please give it a big thumbs up on YouTube, because that helps a lot. If you want to discuss it, leave YouTube comments and all that sort of jazz, or you can jump on over to the EEVblog forum. That's where everyone hangs out and chats about the videos and everything else. Links down below. And also I've got high-res teardown photos of this thing on EEVblog.com. Link again down below. Catch you next time.